There are two types of LCDs: dynamic scattering display, digital pneumatic display. Sometimes it can count as a field effect display also. In examinations, they may teach sometime. Digital pneumatic display, also called as field effect display. First, dynamic scattering display. When the voltage is not applied, the device is transparent. It will appear as transparent. But when the voltage is applied, what happens? The crystal becomes an efficient scatter of white light. These crystals, what happens? They will scatter the light. When the light incident on those crystals, they will scatter. When the liquid is not activated, it is transparent. When the liquid is activated, the molecular turbulence causes light to be scattered in all directions and the cell appears to be bright. This phenomena is called the dynamic scattering. This is simple explanation. How what is the construction of this dynamic scattering displays? It's very simple. It consists of pure pneumatic liquid crystal. This liquid crystal filled in between two glass plates and coated with transparent tin oxide, which can act as electrodes. Very simple. In between the glass plates, put the liquid crystal. Okay. If the electric field is not applied, all the molecules are parallel to glass plate. Here we can see. Material will be transparent. When the electric field is applied, the dipoles of molecules are rotated in alignment in the direction exactly perpendicular to the direction of field direction. That means if you apply in one direction field perpendicular direct to that field, these molecules will be aligned. So the light falls on them, it will be definitely scattered, and hence liquid appears dark in white background. When the light incident on them, because they will be in opposite with 90 degrees, then they will scatter. When the field is switched off, the molecules are locally again rearranged and the material become transparent and the display is erased. That will happen. If you apply the field, what happens? If you remove the field, what happens? Only in alignment of that molecules is the matter. Nothing is there in that. This. Of course, there are some drawbacks. Dynamic scattering display is not presently used because it has shorter lifetime. Its power consumption is very high. It has high operating voltage. These are all the some drawbacks which minimizes to use these dynamic scattering displays. Twisted pneumatic display. It is also similar, simply it is similar to that of the dynamic scattering type, except exemption that two thin polarizing optical filters are placed at the inside of each glass sheet. That means here also the construction is same. Two glass plates will be there. Here two thin polarizing optical filters will be placed inside on each side of the glass sheet. That is the extra construction. You can see the liquid crystal material is kept in between two glass plates as usual, which are coated with the tin oxide. That is common when they can act as the electrodes. This is common like before. The two glass plates are attached with the polarizer above the top glass plate and then analyzer below the bottom glass plate in cross position as shown in figure. This is the common phenomena. You can see clearly here diagram. How it will work? It's only advanced to the previous one. The top glass plate is rotated through 90 degrees. Therefore, liquid crystal molecules are also twisted because the top glass plate is rotated. Here we can see the diagram. Then, if we rotate the glass plate with 90 degrees, liquid crystal molecules also twisted through 90 degrees. Then what happens? In the absence of electric field, under no electric field condition, when the light passes through the liquid crystal, the cell appears bright. Because why? Because the plane of polarization is rotated through 90 by the crossed position of polarizer and analyzer. This is the reason. In the presence of applied electric field, of course, in the presence of electric field, what happens? When the electric field is applied, the twisted pneumatic liquid crystal molecules are all oriented parallel to the field direction. Now they will not be in opposite, they will be in parallel to the field direction. That is the difference. Here there is no twisting of molecules, which is shown in figure B. Here if you apply the electric field, there is no twisting here. That is, there is no transmission of light and the display appears black in white background. When the electric field is switched off, once again the molecule return back to their twisted position. And so display is bright and erased. This is a simple working. Very simple. If there is no electric field, they will be in 90 degrees. If you apply some electric field, then what happens? They will arrange parallel to the applied field. The difference, if you understand, it will be enough. As usual, there are some advantages to search. Very cheap. It requires only low power for operation. They are suited for large area displays. Like that, there are some advantages. If you write 4 to 5, enough. Similarly, there are some disadvantages also. LCD can be viewed only when there is some light, otherwise it cannot be viewed. That is one disadvantage. LCD operating temperature range is very small. These LCDs cannot be operated in high temperatures. LCD is highly sensitive to environmental conditions like temperature change, electromagnetic interference, like that. LCD is very slow device because its turn on turn off time is large. Like that, there are so many disadvantages. So there are so many applications used in watches, clocks, telephones,